Dear students, today we are assembled here for studying equation of motion, as it's belong from the chapter motion, which is your first chapter of physics. So before starting its derivation, let's see what are three equations whichever is studying in 9th standard. But all of you are aware that there is 5 equation, but in 9th standard we will learn only 3 equation of motions. So first of all, guys, let's look here. We are studying chapter motion of 9th standard, and we are going to discuss about equation of motion. So let's equation of motion. There are 3 equations of motion. The first one is V equal to U plus AT. This is first equation of motion. Second, S equal to UT plus half AT square. And third is 2AS equal to V square minus U square. First, second and third. First equation represents velocity time relation. Second state distance time relation, and third shows velocity distance relation. Actually, the equation of motion categorized by their relations. Okay, so we can say that the first equation V equal to U plus AT shows velocity time relationship, and second S equal to UT plus half AT square represents distance time relationship, and third 2AS equal to V square minus U square is equal to it's represent velocity displacement or distance relationship. All of you are aware here that we represent here final velocity of an object or body. U represents initial velocity. Okay, S represents here distance or displacement. Third, time, T for time, and A represents acceleration of body. Clear? Now its derivation is possible in 2 types. The first one is derived by algebraically method, and second graphically method. So let's start its derivation, how it derived by algebraically method first of all. So look at here. First equation of motion by algebraically method. Clear? You can also write here what we are going deriving v equal to u plus 80. Clear? Now, in algebraically method, we are used here mostly formula whichever we have studied in theoretical portion by its definition. For example, for first equation of motion, as we know, acceleration equal to the rate of change of velocity. It means change in velocity by time taken. Clear? The acceleration represented by small a and change in velocity. Change in velocity means होता है final velocity minus initial velocity. Clear? So final represents by v and u. So v minus u. So we can write here v minus u and time taken, let that is small t. So on getting cross multiplication, we got at equal to v minus u. Now on shifting to each other, we got v equal to this is negative, so comes in left side in positive. So we have u plus 80. This is the first equation of motion. Clear? Now let's on second equation of motion. We know that second equation of motion equal to s equal to ut plus half at square. So that you have already looked here, there is a distance or displacement. So total distance covered is equal to average velocity into time. Okay, so let's start from here. As we know that total distance covered equal to average velocity into time. This formula comes by velocity equal to distance by time on cross multiplication. So total distance represented by s equal to average velocity. So average velocity can be written v plus u by 2 and time is t here. Clear? Now on multiplying here, we got t by 2 into v plus u. From first equation, what is first? V equal to u plus 80. So from first, on putting the value of v from first equation over here, we got s equal to t by 2 t by 2 into v plus u. Sorry, over here put the value of v, which is u plus at plus u. Now on solving continue, we got 2u plus at. Now multiplying one by one, we got s equal to 2ut by 2 plus at square by 2. Clear? Now this 2 cancelled by this, and hence we got s equal to ut plus half at square. This is the second equation of motion. Dear students, now let's come to know the derivation of third equation of motion algebraically. So, third equation of motion. Again, since we know that total distance covered by a body is equal to average velocity into time taken. Clear? Total distance symbolically written by capital S is equal to average velocity, final velocity plus initial velocity by 2 into time taken by t. Again, from first equation of motion, we know that a equal to v minus u by t. Therefore, t equal to v minus u by a. Okay. Now, on putting the value of t over here, we got v plus u by 2 into t v minus u by a. Now multiply numerator as well as denominator to each other, we got v plus u into v minus u by 2a, so that s equal to, there is a formula of mathematics, a plus b, a minus b. It can be written v square minus u square by 2a. Now on cross multiplication, we got 2as equal to v square minus u square. This is the third equation of motion algebraically. Now, students, let's come to derive equation of motion graphically method. For graphically method, we must draw a graph first of all, which maintain the distance, time as well as the speed or velocity of a body. For this derivation, let us draw first of all a graph. Look at here, this is velocity time graph. Velocity time graph. It means x-axis represents time and y-axis represents velocity. Now, a body starts to moving from here this is its initial velocity u and come up here. So let this is point having final velocity v. Clear? And in this duration it will take a time t. Clear? This graph used for all three equations. So remember this. First of all, look at this point, and this is origin O, A, B, C, D and E. All the points are mentioned here. Now we can find the value from here. Means origin to V, it is V, and from origin to D it is U. So we can write here the value or distance between B and C, it is V minus U. Clear? From total this AB subtracted, which is U, we got BC. Also the value of DB or OA, it is equal to T. So we can write here OA equal to BD equal to T. This is time. Clear? And DC is a slope. It is slope. Slope represents acceleration because velocity time means velocity by time equal to acceleration. So it represents acceleration. Now OD equal to AB, both are equal, which is equal to U, and OE equal to AC equal to V. Also DE equal to BC, which is V minus U. Clear? So all information here which belongs from graph. Now let us come to know a formula which is slope equal to perpendicular distance by base. Perpendicular distance, और पर कह सकते हैं we can perpendicular height भी कह सकते हैं इसको by base. In this triangle means BCD, in triangle BCD we can write slope means CD equal to perpendicular means BC and base is DD. Now by referring this graph we can put the value here. CD means slope, which is A, BC is perpendicular height, which is V minus U, and BD is the base, which is T. On getting cross multiplication we got AT equal to V minus U. Clear? And hence we can write here, on shifting U on left side we have V equal to U plus AT. So this is first equation by graphical method. Look at everyone. Now let's about second equation of motion, again by referring this graph. Second equation of motion gives us distance. So distance can be calculated by taking area under slope BC. If we can find the area under this curve, there is two things. The first one is a right angle triangle and second one is rectangle. Okay, so we can write here total, for second equation, total distance covered is equal to area under the curve DC. क्लियर? इसके अंदर triangle and rectangle both comes up. So total distance represented by S equal to area under the curve. Have the two figure. The first one is a right angle and second rectangle. So area of right angle triangle BCD plus area of rectangle. So distance S equal to area of right angle triangle. All of you studying in mathematics, 1/2 base into height. So we can write here 1/2 into base BD into height BC plus area of rectangle, length into breadth. So we can write here BD into AB. Now on putting the values of BD, BC, AB from the above, we have S equal to half, value of BD is T, into BC means V minus U, plus BD is T and AB is U, initial velocity U. So we have S equal to, we can write here, this is the first value acceptance for. So S equal to UT plus half T into V minus U. Now by using first equation, which is V minus U equal to AT, from first equation motion, which we have already derived. So S equal to UT plus half T into AT, and finally we have S equal to UT plus half AT square by multiplying. Clear? You can look by pausing the video. Now third equation of motion. Third equation of motion. Again, third equation of motion represents the relationship between velocity and distance. So for finding the distance in this condition, we can also find area of this trapezium. This is a trapezium. Look at here, area of trapezium can be found by using OD and AC is a parallel, and BD or OA is the height distance between them. So again, total distance covered equal to area of trapezium. What is the name of trapezium? ODCA. area of trapezium ODCA. So total distance represented by capital S, area of trapezium. It is half into sum of parallel side into height, or we can say distance between two parallel sides. So S equal to half sum of parallel sides. So parallel side is here AC plus OD and height is OA. This is height and these are two parallel sides because perpendicular. So we can write total distance covered by body or object equal to AC. AC is V minus U plus OD. OD is T. OD is U into OA. So OA is what? OA is time T. Look at it again. AC is total V, already written here. AC means from here to here, which is V. OD means this is, which is U, and OA time T. Now S equal to half into V plus U into T. Now again देखिए, we can put the value of T since A equal to V minus U by T. Therefore T equal to V minus U by A. Clear? Now by using this first equation of motion, we can put the value of T, which is V minus U by A. Now multiply V plus U into V minus U by 2A. So S equal to V square minus U square by applying formula A plus B, A minus B equal to A square minus B square by 2A. Finally, we can write by cross multiplication 2AS equal to V square minus V square. Clear? So students, today in this episode we have learned derivation of equation of motion by algebraically and graphically method. Clear? In next episode we will learn numericals based on motion and equation of motions throughout the chapters. Okay? Jai Hind.